Hey guys, welcome back to another video. Today we're going to go over analog versus digital in terms of sensors. Let's get started. Okay, I'm going to demonstrate this with two examples, an analog distance sensor from Pololu and the TSSP438, which is just an infrared sensor. So this one is digital and this one is analog. So if you would monitor these and if you would connect these up, these guys would return these kinds of graphs. So let's start with the TSSP. This one is an infrared sensor, so if you would expose it to infrared, it would return this kind of graph. And the lows would be represented by 0, and the highs would be represented by a 1. So this is how it would send data. So there is no in between. It is just either a 0 or a 1. It either sees the ball or it doesn't. It's kind of like a tripwire. It either sees it or it doesn't. That is what a digital sensor is. It's either a 0 or a 1. Now, analog sensors, they pack much more data, but it's actually more prone to noise. So if you would see over here, um, the signal is very not like it doesn't jump. It represents values from 0 to 1 and it can do values in between. So it can, for an analog distance sensor, it can represent like, let's say if this was 0 meters and this was like 3 meters, it can represent 1.5 meters right here. It can represent 1 meter right here. And so it's much more information right here than a digital sensor. Um, and but the thing is, it can be prone to more noise. So what noise is the occasional like up and downs of the graphs like this, right? If it's analog, then you are really relying on that exact point. So it would be prone to noise. So you would kind of have to average that in order to like get rid of the noise. But over here, even if there's a little noise, it would all just be counted as a 1 or a 0. So it's very, very resistant to noise, which is pro to digital. Um, there is a way to convert a digital signal into an analog signal, but I'll go over that in another video. It's called a low pass filter. But yeah, this is the difference between an analog, which is smooth, right, and a digital, which returns only a 1 or a 0. Hopefully, that was helpful. Over here, I have the teensy pin out. These are the analog pins, so you can connect sensors that output analog to these and monitor them right there. And all the gray ones, so like all of these can monitor digital. That was an example on the Teensy 3.6 microcontroller, which I recommend. It's very good. Um, but yeah, hopefully you guys found this helpful. If you did, smash that like. And if you have any questions, I'll be happy to answer them. Comment them below. And yeah, see you guys in the next episode.